existence for one or another living organisms. Of course, they eat what they find in our body, and I'm talking here about the microorganisms. So diet, and once again, diet is extremely important. And so, for instance, when we see mice which are fed with a high-fat diet, there was a decrease in bacteroides, increase in Firmicutes and protein bacteria, the old study by Hildebrand, and the change in microbiota occurred regardless of whether the mice were obese or not. So you see the trend. So even if they're obese, if you're on top of the obese phenotype, feeding them with a high-fat diet, you can see the negative changes in the composition of the microbiota. There are some controversies, of course. Fat diet, germ-free mice gain more weight than conventional mice. And probably controversy is not the right word. Question. And my question here is perhaps the role of diet. Again, the role of diet should not be underestimated, and that may also influence significantly the outcome of what is happening in the eukaryotic organism. Some bad news on the fat associated with fat bacteria. A couple of examples here from several studies. And these are important as a take-home message to build a foundation of our understanding what is actually happening through the course of the development of the obese phenotype, what is happening at the level of microorganisms. So the introduction of gut microorganisms, the germ-free mice, resulted in the 6% increase of body fat and insulin resistance compared to the germ-free mice. Now, the key words here, gut microbiota. It doesn't say gut microbiota from obese animals. So, in other words, is that you picture this situation. You have germ-free mice, and they used to live in this condition. And some of my students were asking, could it be that being free of any germs, of any bacteria, is better for us? Well, of course, it's a hypothetical scenario, and the answer would be, well, we cannot survive unless we are surrounded by the bubble, which doesn't allow for anything to come from outside. But it's an interesting question how these organisms survive, how they live, and not only at the level of the digestion tract physiology and functionality, but I don't know about the brain function, for instance, because we do know that the microorganisms are involved in these processes. I don't know how about the endocrine system. All right, but the interesting thing here is that introducing the microorganisms in the germ-free, even though that they're healthy microorganisms, it's a stress. Everything that is different from what the host is used to is a stress. It's a good stress, but the eukaryotic host needs some time to adapt, to understand what is going on. And of course, these kind of seemingly negative at first